Hello everyone, welcome to the GeekNarrator podcast. I am your host Kaival Apte and I am back with another episode. Today we are going to talk about scalability and fault tolerance. As developers, we keep talking about how to make our system scalable and fault tolerant, but do we know how to ensure that? What are the practices we could follow? To discuss that, I have someone who has vast experience in system design, Arpit Bhayani, and he runs his system design cohort based course. He is a director at an academy, and he shares a lot of insightful posts on LinkedIn and also has a newsletter. So I am really excited to have him on the podcast today. And thanks, Arpit, for joining.
Thanks
Let's
for
start with a little bit of introduction for some people that might not know about you yet.
a lot are there. Okay, thanks so much for having me, Kavanya. It is a pleasure. So to start with a very brief intro about me. My name is Arpit. Have been working with an academy for 4.5 years now. I joined when it was not very early, but I joined when it was valued at around 100 million. Have been fortunate to be part of that rocket ship that is now sailing at 3.5. So
Wow.
pretty interesting times. Was their first technical architect. So one very interesting thing happened is when I joined, I was asked, "Ki, Harpit, please find a problem statement that you would want to work on."
Hmm.
I said, "Search is broken." He said, "Work on search." So out of nowhere, I started building search for an academy,
Hmm.
along with basically ensuring everything scales and all. So that happened. And in just immediately when the lockdown happened in India, we had a data breach, gigantic data breach. We were like,
Hmm.
"God, kya ho gaya?" And what happened was, it was first time we operating remotely, and data breach happened. Hacker was in the infra. We didn't know about it. We had to fix it. How do we do that? So it was brand new experience on how to mitigate such outages and all. Not really outage, but security incident. Mostly like around data breach. That's a big deal. Uh, so then they saw Arpit knows infra. Let us make them basically let us make him manager of SRE. So that's where
Hmm.
I started going into leadership role. Built entire SRE team ground up. Built that for 2 years. Now very recently transitioned into data engineering domain. So now I'm currently leading a data engineering team over here. Apart from mentoring staff that's there.
Nice.
Prior to this, worked at Amazon, Practo. Have been very fortunate throughout my career to have worked on some really amazing systems through which I've gotten these insights.
Hmm.
And was a very studious student in the college, so I have very strong foundations. Key how database work, networks, computer architecture, all of that. So that helps me scale system. So yeah, that's about me from professional side. Apart from that, I run a YouTube channel, post 3 videos every day. Newsletter is there. I love to read research papers. Love it. I
Mhm.
love to dissect systems, dissect outages. So whatever I learn, I share it via YouTube and newsletters and whatnot.
Awesome, awesome. Yeah, I mean, I've been following your YouTube channel and also LinkedIn, the newsletter. So as I said, it's really insightful, and thanks for doing that. It adds a lot of value to the community. And before we start with the actual thing,
Hmm.
let's share if you have some kind of fun fact about you, um, just which is not like known
Yeah,
widely as of now.
yeah, that's a very interesting one. So I spent 2020, the entire lockdown, I
Hmm.
spent learning Morse code. And I just
Nice.
and I became not so good at, but I became pretty decent at it,
Hmm.
that whenever I hear Morse code, I can write English. Basically I can convert Morse code to
Wow.
English to Morse code seamlessly. So I have
Nice.
spent roughly 8 months every single day, 2 hours into basically building that pattern, because it's very hard. So it's
Yeah.
easy to actually memorize it, that's fine. But converting from English to Morse code to English is also fine. It took me 6 months to
Hmm.
basically practice an auditory input. So when I
Hmm.
hear beep 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 beep, so understanding where the space is or where that void sound is, it's really difficult. It was such a pain. I never thought I could do it, but It took me 8 months, 8 months, but yeah, now I can very seamlessly translate English to Morse, Morse to English, even audio. So yeah, that's very fun.
Wow, that's really interesting. I mean, I ask a lot of people about their fun facts, and this is like one of the most interesting and different fun facts to know about. So thanks for sharing that. Great. So I'm really excited to start. So let's start with, as usual, basics. So when we say scalability and fault tolerance, right? So
Hmm,
let's define these terms. So when we say scalability of a software architecture or software system, what do we
hmm.
mean?
So scalability in general, like the way one should think about scalability is that we should be able to handle large number of concurrent users without degrading the performance.
Hmm.
Every single word or every single clause is very important. Ability to
Hmm.
handle not just large number of users, but large number of
Yeah.
users concurrently. And when we do it concurrently, we should not be degrading the performance or the experience of our end user. That is
Hmm.
scalability. Because
Yeah.
you can say, ki, hey, I'm able to handle 1 million users, but if you cannot handle 1,000 concurrent users, then you are not scalable.
Yeah.
You can handle 1 million concurrent users, but if your site is not working or your experience is degraded, that is also
Hmm.
futile. So it
Yeah.
has to be balance between the two, where you can handle large number of concurrent users without degrading their experience. So that's
Yeah.
what scalability typically
Awesome, awesome. Yeah. And I think just to add a little bit,
is.
I think cost is also a concern there because some systems can scale if you just throw money at it, like add more machines and it will scale. So
Hmm,
it needs to be also cost effective. And that's when I think all the optimizations and the techniques come into picture. But yeah, I think it's a pretty clear definition, and it's like
hmm,
there are two parts to it. And as you rightly said, and let's define fault tolerance now.
hmm. Just one thing to add on the cost side.
Yeah.
Real systems are always cost efficient. You cannot leak money,
Yeah.
right? So theoretically, you can design a super complex system
Mm.
with basically thousands and thousands of machine. In real world,
Mm.
when you want to translate, you'll not get an approval from your tech architect or your staff
Yeah.
engineer or even your leadership. That hey, why are you
Exactly.
leaking this much of money? This is the biggest cost center that you have. So real
Right.
systems are always cost efficient. So what I like to call it, real system design is always cost driven design. It's neither to handle scale, it's neither to handle fault tolerance. It's more about, hey,
Yes.
are we able to sustain the revenue with the
Yeah.
cost that we are incurring? We should not be leaking
Mm.
money. It's okay that we are not giving sub millisecond latency,
Absolutely.
but we need to ensure that paisa, like basically the cost becomes the biggest factor over here.
Exactly. Sustainability
Yeah, yeah,
is
yeah.
what drives things. Okay.
Yeah. And then coming to
Great.
fault tolerance part, fault tolerance is something which is very critical. Like
Mm.
because fault tolerance is basically we being able to sustain any hit that we are getting. When I say hit,
Mm.
it's like someone basically punching in your face. How are you protecting yourself against it? A
Yeah.
simple example, my API server goes down while handling the request. I should not be
Mm.
having an inconsistent data. So here,
Mm.
when people think about fault tolerance, it's mostly about, hey, my service should not go down, or if one of my node goes down, my service still should be up and running. That is still a
Yeah.
partial definition. So,
Mm.
easiest way to implement this is take a bunch of API servers, put them behind a load balancer. Load balancer is doing the fault tolerance part for you. So, if one of the server goes down, it would stop sending requests to that machine.
Right.
But more importantly than that, what about data? Fault tolerance should also be is also very important that your data consistency is maintained. That no matter what happens,
Yeah.
even if your system goes down, your data does not go in an inconsistent state. And that is much difficult to build as compared to having fault tolerance on an API server. So fault tolerance, end-to-end spectrum of it starts from your API servers being fault tolerant, your
Hmm.
processes systems being fault tolerant, your low-level code becoming fault tolerant, your data is also fault tolerant.
Yeah. Makes sense. Um, I think you covered some interesting points there. So
Hmm.
when you said that, like replacing servers and being available is one thing, but being consistent and being correct with the data is also important. And it's, I think, more important and critical because customers see the data.
Yeah.
They might feel a little like unresponsiveness in your website, but that might be okay. But if they see inconsistent data or inconsistent
Yeah.
behavior, that might be a big of a problem. So
Yep.
great. So I think we have a like a clear understanding of what we mean by
Mm,
scalability and fault tolerance. Let's dive deep into the approach, right?
mm,
How do we ensure? So let's say I'm developing a system, I'm designing a new software system. How do I go about scalability, and what is the time I should think about scalability? Is it right from the beginning? Is it somewhere down the line? When
mm.
is it?
Okay. Here, what I think is it depends on the organization that you're working for. Let's say, to start with, let's say you're working in a multinational company, let's say Amazon,
Mm,
Google, Uber, Microsoft, and all. There you have to think about scalability from day zero. Because when
mm,
you are shipping your product to someone, you're by default getting a million users on your platform on
yeah.
day zero. So that's why you have to be thinking about scalability from day zero. If you're
Mm,
working on a mid-sized company, your scalability is still okay. You're not handling massive scale. So
yeah.
what you might do to get the best scalability thing, your best performance of your system might be an overkill for our organization because it would
Mm,
leak money. Of course, to
exactly.
get that much of performance, you need to put in that much of money.
Right.
So for a mid-sized organization, it could look something like, hey, I'm able to sustain the load. It's scalable enough that it would work for next 1 year. Right.
Mm,
Next 1 year ki growth is like you are able to justify or you are able to support the next 1 year of growth. Good enough.
mm,
But if
yeah.
you are startup or if you are just early stage company or you are starting on your own, don't think about scalability at all. It's a waste of
Mm,
time. You don't even know if you're going to survive or not. Right?
yeah.
Survivor of the fittest is what you should be thinking on. Like
Yeah.
imagine you starting up a company and spending a ton of time building 50 different microservices and zero customers. What's the use
Yeah.
of 50 microservices to get scalability and whatnot? I personally made that blunder. I was trying to build a product.
Mhm,
I was just fresh out of like I had 2.5 years of experience. I'm like, chalo, let's do startup or build product. And obviously, I did not leave my job at that time, so I was doing it part time.
mhm,
And what I did is I built 7 services. My product did not work well, but I had
mhm,
7 services, bought AWS reserved instances and all, hosted.
mm,
Did not I forgot to bring in users, and eventually I wasted 20,000 rupees on that without having any substantial output. So that's what my hard-earned money when I went to AWS bill for no real reason. I realized, okay, we should not be thinking about best because that was because my first experience. It taught me best way to design it, and I thought, "Ki chalo,
yeah.
authentication one service, image processing one service, image
Yeah.
upload another service. It doesn't work that way. So that's where early stage
Absolutely.
startup or when you're starting up or early stage, think about survival. Whatever it needs to be done, do it. Don't think
Yeah.
about scalability at all. Throw money at our cloud provider, vertically scale your system. Don't think too much about it.
Absolutely. That makes a lot of sense. And I can also share one experience here. I
Hmm,
think it's relevant because you raised a very interesting point. So it depends on the context, right? And ultimately, it's about money because you
yeah.
want to launch your product, you want to get some customers, you want to eventually get some money, and then you need to think about scalability if you ever reach there, right?
Yeah.
If you don't reach there, it's no point. So I was working in a like a large scale company, but they had like a new product
Hmm,
feature to
hmm,
launch, and they wanted to try it first, right? So they didn't go like full blown and we
hmm,
want to like really make million euros out of it, but they wanted us to try first, and then they asked the development team like how much time you think we need to build this feature.
hmm,
And we said, okay, I think it will take 2 months because we need to ensure scalability, and we
hmm.
also need to do a lot of testing and all that thing. And then they were like, we have 2 weeks, can you do this? And then we're like, okay, but we have to deal with like lack of testing because we don't have that
Hmm,
much time.
hmm,
We cannot follow, let's say, the so-called microservices pattern. So the architect said, do we need that? We don't know yet, right? So let's go with like a simple monolithic application, use a simple postgres deployment, and let's run it. And it really went well. We got customers, and it worked quite well, like for I don't know, 2 years.
hmm,
So as you said, scalability depends on the context. You don't need to think right from the beginning
hmm.
if you don't have that customer base
Yep.
yet. So
Yep.
follow the basics and you will reach there. Great. But let's say that I am working in a big organization,
Hmm.
and I really think that this is the feature my customers want. I've
Hmm.
done the initial testing, right?
Hmm.
And now I have to inject that scalability into my system. How does that work? What are the steps to, ensure that?
So, uh, the approach that I have taken the most in my life is assuming, like whenever I would want to ensure that I'm handling the scale or I'm able to handle the scale well, it's always about let's be as pessimistic as we can be.
Mm,
After every single line of code, assume this would break. After
yeah.
every single line of code, assume your entire infra breaks, and
Mm,
see if you are still if you're still in a consistent state or not. And
yeah.
if you think about it, if you be very pessimistic with your approach, you would always design
Mm,
robust systems. Right?
mm,
And that is
yeah.
exactly how you should be thinking about handling the scale and being fault tolerant at the same time, because these two are not independent of each other. These two
Yeah.
go hand in hand. Right.
Yeah.
So you able to handle the scale but not being fault tolerant, of no use. You're not
Yeah.
able to handle the scale but you're extremely fault tolerant, again of no use. So
No use.
that's
Yeah.
where assume that after and that's a very simple way to approach it. Assume after every single line of code, your process would crash, your disk might crash, or your server goes down, your database goes down,
Mm,
cache goes down, the network is congested, whatnot. Think the
mm,
worst that could happen to anyone happens to you after every line of code, and see
yeah.
how your system reacts. And
Yeah.
that is a good way to do it,
Mm,
to see. And then once you identify that, fix that and see if you have improved or not. And it's all about, and it would all happen in your head. You don't need to
mm,
simulate models to check how it happens. With time, you
yeah.
would understand, okay, hey, if it goes down over here, am I running, like simple example, am I running if I would want to run a bunch of SQL queries, are they being run in a transaction or not? If they are
Mm,
not executing in a transaction, which means your database might go in an inconsistent state. Right?
yeah.
Let's say if you're taking down your server, what would happen to your existing request which is being served? Are you gracefully
Mm,
terminating it or not? Right? Think about those steps. Get how are you reacting to a very catastrophic situation? Right?
yeah.
And that would help you handle scale and this. But there are still few things that you can have a checklist about. Like for example, especially this holds true when you are designing a distributed system, that take
Yeah.
very baby steps. Don't
Mm,
directly jump. Like for example, if you would want to design if you want to design an image upload service, who only takes care of
mm,
image upload. So instead of doing,
yeah.
hey, I'll take my image and directly upload it to S3, you can say,
Mm,
ki, my server would send a request, it would send a response with the signed URL, then you would upload it to S3. So
yeah.
because computers are dumb, we tell them what to do. We have to exactly tell them what to do. Our brain can
Yeah.
work 100 times faster on
Mm,
anticipating what's next. Computer cannot do it.
yeah.
So we have to exactly tell computer what needs to be done. That is where we we ourselves needs to be very explicit in defining on what needs to be done. This is where the biggest
Yeah.
gap is. Most
Yeah.
people are not able to build fault tolerant and scalable systems purely because they jump the gun.
Mm,
Take very baby step, because your computer is stupid. That you have to tell it exactly what needs to do or what needs to be done. That is where you yourself, you'd think, "Arey, this is such an obvious thing." No, it is obvious to your brain, not to the
yeah.
computer. This is where you
Yeah.
need to detach yourself. Let me
Yeah.
take baby steps to do that, and that is where sometimes flowchart or class UML diagrams come in very handy.
Yeah. Yeah. That makes a lot of sense. Like taking these baby steps or incremental steps, slowly moving towards your goal, makes a lot of sense, because even while you're coding,
Hmm.
right? If you have the solution in your head,
Yeah.
right? But you inject those bugs because you're trying to jump the gun, and you're writing, you're not thinking one step at a time,
Yeah.
and you're just uh, like running before yourself. So um, I think that makes sense. So the idea was to go as pessimistic as possible and think about the failures, right? Um, and then ensure that the behavior is correct
Yep.
when such failure happens. And I think there's only one thing which is common in, a developer's life and software's life is failures, because some failures cannot be avoided. I mean, there are some failures which are, let's say, process failures. So we didn't follow a good process and then we ended up in a failure.
Hmm.
We can fix that by looking or doing a post-mortem and seeing how we can improve.
Hmm.
But there are some failures like hardware failures, as you said, like network failures, disk going down, and there are other failures like cache server going down, memory issues, CPU issues. There are so many other failures, and they're bound to happen because there are so many unknowns
Yeah.
and so many moving parts in a software system. um, so you cannot avoid that, but as people say, you can only gracefully fail, so it doesn't translate it into a bad experience
Hmm.
to your customers, because at the end you are serving someone, and if it's a bad user experience for them,
Yeah.
it is not going to
Yeah.
work.
True.
So how do we translate those failures?
Hmm.
So let's say there is something going wrong
Hmm.
in the network,
Hmm.
right? And how do we make sure that it doesn't reach up to the customers? So customers, so abstraction is like
Yeah.
of utmost importance,
Yeah.
right? Whatever happens, if you have a distributed system, your customers do not care,
Yeah.
right? If you have a distributed system or non-distributed system, so they shouldn't know if there is some failure.
Hmm.
So how do we ensure that this abstraction isn't leaked?
That's an excellent question. I'll give a very practical answer to this. Uh, Imagine Xiaomi is running a flash sale. Flash sale,
Yeah.
a lot of people come in a very short window of time, and obviously systems go down, right?
Mm.
And things would go buzzard, backend might not working, or a lot of users have come in. So every other user who is trying to come might just see an infinitely running loading screen, something like that, right?
Yeah.
Now that
Yeah.
is a very poor experience. If you show user
Mm.
that an infinitely loading screen, that's very poor user experience. So how can you make it better? Right. So this is a
Mm.
very classic case where your backend is overwhelmed. Your users should not know that your backend is overwhelmed. You want to give your user a very deterministic answer that, hey, wait, we are saving or we are seeing large number of users clocking in. You are
Mm.
on waitlist number 12, for example, right? This
Yeah.
That is a good user experience. A poor user experience would be user coming onto the website and just waiting.
Yeah.
Something would happen, but nothing happens,
Mm.
right? So
Yeah.
telling user that something is down, telling user that you are in the wait list, telling user that, hey, we acknowledge your problem, or we understand that we are under stress, but not telling user that you are
Mm.
under stress, right? But
Yeah.
giving them that notion, and this is a very solid example where flash sale, so where basically flash sale fits, where flash sale sits very nicely. So what you can do,
Mm.
you can have a you can have a switch, which when you know that, let's say you would want to sell 1 million, let's say you want to sell 100,000 items, right? And you
Mm.
got, let's say, 200,000 users already in. So for
Mm.
200,000 plus one, that user, when he or she comes in, you should not be taking him or her in.
Mm.
As soon as 200,000 people happens, you would turn the switch on. Key.
Mm.
Now, anyone who visits the page directly sees a result. Key. Our
Yeah.
flash sale is over, or maybe a
Yeah.
waitlist information, depending on how you'd want
Yeah.
to design. So here, it's literally abstracting out the overwhelmed backend infra that you have, or the architecture
Mm.
you have, by showing a pretty message to your user, where key higher, basically your flash sale is over. You can, because you are sure that
Mm.
200,000 people would purchase 100,000 items. Very
Yeah.
very rare chance that
Yeah.
your 100,000 items are not sold with first 200,000 people who have come in, right? Very rare chance. So
Yeah.
you can directly tell user the flash sale is done, all items are sold, rather than making him or her wait on that page.
Mm.
So
Yeah.
such situations, every place have those circuit breakers, where
Yeah.
people think about circuit breakers mostly from the back end side of things, where they would think, hey,
Mm.
my service A is calling service B, and my service B is down. I don't want my service A to call service B. So you can add a circuit
Yeah.
breaker there, right? But think
Yeah.
about circuit breaker on your end user side, where you don't
Mm.
want to show your end user on,
Yeah.
or you don't want to give them poor experience. Show
Yeah.
them the error message, a sweet little error message that would tell them keep maybe flash sale
Hmm.
over or something like that, which would help you
Yeah.
design your system better and give a very pleasant experience to your end user. And that is extremely important.
Absolutely. Yeah. That's a great point. So the concepts of circuit breaker as we use on the backend system. So if something is going wrong, we just open the circuit so it is not
Yeah.
able to hammer the service which is already down and consume resources. Um, but that analogy that you gave, like how to circuit break on the user experience, which is really great because it's like fail fast. If you already know that there is a failure happening, just fall back, just give some static response to the user, such that it's not terrible experience. It's still
Yeah.
bad, maybe that, oh, the flash sale is over,
Hmm.
but it's not terrible that, oh, waiting and not getting anything. So on that, I like to add another example which is very similar to what you
Hmm.
said. So it's like you have those delivery options on the, if you're buying something like on
Hmm.
e-commerce, you have delivery
Hmm.
options like premium delivery, express delivery, and then 3 to 4
Hmm.
days and default one. So sometimes when there is like high scale and the delivery service is not able to keep up
Hmm.
to give you like real
Hmm.
estimate based on the pin code or something, you can just show them the fallback. So whatever delivery it is, it will take up to seven
Hmm.
days. I have seen this happening mainly, let's say, on Black Friday or
Hmm.
something, because on Black Friday, people want to proceed with their
Yeah.
order.
Yeah.
They
True.
don't care how late their product will be delivered because they are getting it for a very cheap
Yeah.
price. So that is a like a trade off you're
Hmm.
making, right? So it's not bad customer experience. It is, maybe you can still deliver them within three
Hmm.
days. So that depends on a lot of other
Hmm.
things. But fallbacks and these default using some switches is great when you want to control the behavior
Hmm.
or
True.
stop the failures from reaching to the customer. So this is a great point. Now, so we talked about what is scalability, how do we ensure
Hmm.
scalability, how do we go about like organization level.
Hmm.
So uh, process level. So let's say we are a team, let's say, of 4 members. We develop a system,
Hmm.
we have fair bunch of users, but we haven't tested, we have no proof that the system can scale up to, let's say,
Hmm.
10,000
Hmm.
users. How do we go about that? What is the process difference or process that we need to build?
So this is a super critical point. Like most people, what I have observed, I've
Hmm.
worked with so many companies, and one problem that stitch them all is they don't know what is the limit of their one machine, which is such a
Hmm.
trivial thing. You should
Yeah.
know for a particular microservice, even if you have monolith, for a particular service that you have, what is the limit of that one machine running that one service under a specific load? If you
Yeah.
know that number, you can linearly amplify and add, and
Hmm.
you can do solid capacity planning. For example, if you know that one machine can handle 1,000 users, if you are getting 100,000 users, how many machines you would want to add? Normal speed distance time
Hmm.
problem, right? So you can
Yeah.
very easily find out how many machines would you need, or will you be able to handle the scale or not. This one
Hmm.
very simple number people tend to miss, right? And the way to
Yeah.
get this number, people say ki, yeah, there are so many things that I cannot know. For example, what is the current state of the database, how much load is it on the I know there are a lot of factors, there are a lot of factors,
Hmm.
but even a rough estimate goes a long way. And how do you
Yeah.
identify it? Spin up a small server, which is of
Hmm.
exact same size that you have in production. Run a small load test. You don't need to run million requests per second. One machine is never going
Yeah.
to handle million requests. That everyone knows. So run a small load
Yeah.
test. One small locust server or JMeter. Use your favorite tool. Fire the query and see how it responds. You might not be able to simulate your production environment. You don't need to,
Yeah.
but at least you would be able to know the magic number. You'd know how much one server can handle. With that load,
Yeah.
with proper monitoring setup, you can exactly know where your potential bottlenecks are. You can fix them.
Hmm.
You can fix them and handle larger load, right? And
Yeah.
it's a rabbit hole. You might be, because
Yeah.
wherever humans see number, We tend to optimize that. That's how ranking
Yeah.
works. Array, why am I at fifth rank? I want to be at first. Right? Whenever we see number, we are so obsessed. Human race is so
Yeah.
obsessed with numbers. And we always, and once
Mm.
we start to quantify something, we love to go in that direction. Yeah, let me just make it better and better. You'd see so many times people running unit test, finding code coverage, unnecessarily trying to complete a 100 on 100 unnecessarily,
Mm.
right? You don't need to, but we are so obsessed with number that we can't help, right? And that happens. This
Absolutely.
would also happen when you do load test with one machine. You would suddenly try to think, Array, I'm able to handle, let's say, 100,000 requests per second. Let me go a little notch up, right? But
Mm.
understand where you need to stop and solve that problem. But up until the
Yeah.
stage where you are not delaying the shipping of your product, right? So
Mm.
load test on one machine is something that everyone should be doing. That gives
Yeah.
you a very nice benchmark. Uh,
Yeah.
but if the organization is having a solid engineering maturity, that's where what you can do is you can have a parallel infrastructure, replaying production traffic onto your parallel infra and seeing how it
Mm.
behaves. But it does require a lot of engineering maturity to pull that off. And most companies don't have that. And it's very difficult. It's very difficult
Yeah.
to set up parallel infrastructure. Infrastructure as a code, everyone
Yeah.
knows infrastructure as a code, but it's so hard. It's so hard
Yeah.
to ensure that spinning up a microservice or creating a replica of a microservice is a piece of cake. It's extremely difficult. So that is where
Yeah.
you need a lot of process level maturity, engineering excellence in the organization to pull that off, and
Mm.
plus
Yeah.
ability of organization to invest in that. Here, let's go towards engineering excellence because most companies today in basically today's day and age, they're struggling with revenues, let alone engineering excellence. So
Yeah.
yeah.
Absolutely. So you covered some very basic yet so important points that you know load test on us for a single machine, and that is so important. That's where
Yeah.
you start, and that I think comes back to what you said initially, that take the baby steps. You don't need like a cluster level load testing just to figure out some initial bottlenecks in your system. So rather than doing nothing because you don't have that maturity, it's best to just do something and identify the bottlenecks as much as you can. And I think it boils down to identifying the
Yeah.
bottlenecks and then making the trade-offs, right? What is more important for you? So as you said, even running something on the local machine can identify some bugs, some bottlenecks, and that's so important. And that's it's so cost effective as well, right? Because you just need your local machine. You don't need a server on some cloud provider to run. And then and also getting it right, as you said, creating those parallel infrastructure is so hard. It takes money, it takes time, still can things can still go wrong, and you're not sure you're absolutely creating like a mirror
Yeah.
of production,
You
because you
can
can
never.
never
Yeah.
create a mirror of
Yeah.
production. So you just have to like do a best effort kind of thing. um, so yeah, that's a great point, that you know test as local as possible, and then build on top of it, and break down
Yeah.
one machine and see what is the hard limit on that, and then grow on adding. So talking
Hmm.
about that, you also said replaying the production traffic on for
Hmm.
load testing, just to so I think the point is to be as close as production environment as possible, because
Yeah.
that's what you want to test. How do we go about it? So I've rarely seen companies, I've like so far I've only seen one company running load tests on production
Hmm.
environment, and that took like really huge efforts, because they used to prepare for months, because every team needs to have some switches.
Yeah.
What happens if something goes wrong, and how do we remove the data after the fact, after the load test is done? What do we monitor? How So the key point is to not impact the production traffic. In any case, they shouldn't
Yeah.
know you're load testing your system. They don't care. So what in your experience is the right way to do it,
So what I've
for different
so what I've
companies?
observed over here is like most companies who want to do load test and are not. having a parallel infrastructure to set up, they typically like they run load test on production. So simple.
Mm.
Again, I'll start very simple. Do it during VRs. So let's say you have traffic from
Yeah.
morning 9 to let's say late night around 10, 11. Do it at 12.
Yeah.
Do it midnight. Right. And test your
Mm.
systems, how it is working. Because in most cases, companies don't have a luxury of having a parallel infrastructure set up and what it requires very deep expertise into first of all building that,
Yeah.
second managing that, third ensuring that the cost doesn't shoot up, fourth doing cleanups and all. So many things to take care of. That's where do it in the VRs. That's the
Yeah.
easiest way to do it. In case your company works around the clock and you don't have a VR time, so a strategy that I've typically employed with a couple of orgs is we create a parallel infrastructure. Like for example, if I want to talk in terms of AWS, in AWS you have auto scaling groups. Create a parallel auto scaling group. Have a separate endpoint.
Mm.
So let's say you are working for a company, let's say abc.com. So you have api.abc.com,
Mm.
right? Create a separate auto
Mm.
scaling group, a separate Route 53 entry, and let them hit because in most cases, whenever you are load testing, you are testing your database. You're not testing anything else.
Mm.
You're testing how, because if
Yeah.
your database can handle the load, everything would just work fine because everything else is stateless. Your load balancer is stateless, your API servers are stateless, your bunch of microservices are stateless. The only thing that is
Yeah.
stateful is your data stores. It could be your cache, it could be your
Mm.
database. Right. So given that you are only testing your database, what you can do is have a parallel setup with a separate R53 entry, separate production, separate auto scaling group, and because of that separate thing that you have forked out, it is very easy to monitor.
Mm.
With a separate auto scaling
Yeah.
group, separate target group, separate set of servers, you can very easily monitor on how this new thing is behaving under load. Right?
Mm.
And at the end, what would be affecting? Because everything else is
Yeah.
stateless, the only thing that would affect is your
Mm.
database. Right? So
Yeah.
when you are testing that, start with a very less load and slowly up the entry. Given that you are testing in production, you have to ensure that your end user experience is not hampered. So you have to start
Yeah.
really very small and then slowly up the notch, or rather exponentially up the
Mm.
notch, and see how your systems are
Yeah.
behaving. But until a certain stage, when you feel even a
Mm.
slight risk that your DB might crash, immediately stop it.
Mm.
I've seen production outages because they ran load test in production with directly starting with 100,000 requests per second. I'm like, why? Don't do that. Wait, start small
Yeah.
because
Yeah.
you don't want an outage because of a stupid load test that you
Mm.
would want to run because and you'd want to run in production because you don't have a parallel infra setup. So that should be your final resort, but you have to like some companies, for example, if you're preparing for Cyber Sunday or sorry, it's basically Cyber Monday or basically Black Friday or Amazon Prime Days or
Yeah.
whatnot, they had such such once a year events. You typically would want to
Mm.
load test in your production to see if everything is working fine or not, and that is a very
Yeah.
and you should do it. I'm not at all denying that you should never load test on production. You have to do it at
Yeah.
least once before a mega event in your organization. Before that gigantic mega event in
Absolutely.
which a lot of marketing budget has been spent, you should at least test your production
Mm.
infra once. Because if you're not testing that, what if on that big day it goes down? So that is where every
Yeah.
single organization, whenever they are having this mega events, right, they would run a load test in
Mm.
production. But day-to-day load test
Yeah.
happens on a separate infrastructure and it doesn't happen in production, but one
Yeah.
it definitely happens in production.
Absolutely. Uh, Again, some great points here. Uh, I think so. Start incrementally, start small, but increase the load. And doing it on production requires a lot, cautious process that if something goes wrong, what to do. So I remember a case when we didn't have that much
Mhm.
maturity on testing on production, and we said, okay, let's test on production and let's go small. We'll just test something, and then we should be able to identify the data that we created as
Mhm.
part of load test, and we'll just clean up. But there was a bug, and that data did not have any identification that this belongs to load test, and we created like, I don't know, a
Mhm.
lot of data. which we could not delete because now we don't know if it's real customer or not. So that was a mess. And I remember, like, I was also kind of involved, but not directly, but it was a mess. So running on production is ideal, but it needs a lot of maturity, and it's not necessary. There is a lot of things, as we earlier said, you can do it on your local machine, on a replica, or the parallel infrastructure. uh, and you don't need to go like 1000 requests per second if that is not your business requirement. If you want to support 100 requests per second,
Yeah.
it's okay. You don't have to go crazy and just test your software, because it has cost. You can do a lot more other things, like adding new features to your system that
Yeah.
is more valuable to your customer. So having that business context is really important. For example, if you're just launching your alpha and you expect like 10 customers, then you
Mm,
don't need that much of an effort on load testing. uh, Great. So I think, so there are, so let's say we have to run a load test on a parallel
mm,
infrastructure. We have that
mm,
setup, it's all good. And now we have to do this on like production
mm.
like environment. But for some reason we cannot, let's say for compliance reason, we cannot use the direct production data because
Yeah.
it has some
Mm.
PIIs and all that stuff. So how do we go about imitating that traffic in the replicated environment?
So there are few tools, basic very open source tools that you can use. What in any case, what you would want to definitely replicate is how your traffic pattern happens in production. Like for example, if you're seeing a
Hmm.
sinusoidal wave throughout the day
Yeah.
in your traffic, you would want to ensure that a similar pattern is applied on your parallel infrastructure. So there are tools. So now what you can do
Yeah.
is, let's say you might have your access logs, your VPC logs. You can replay your VPC flow logs if you would want to. You can replay your
Hmm.
API access logs that has come to you, that has hit your infra. For example, for your service, you would be logging the request that has come in,
Hmm.
which might be flowing through an ELK stack in your Elasticsearch and visualized through Kibana and all. So
Yeah.
get those logs, but you obviously can get logs of, let's say, 2 days, and you would be simulating that as
Hmm.
exact same request on your parallel infrastructure. And the way you can do it with, there are a lot of
Hmm.
tools. Like JMeter also has this ability to replay the logs. AWS has a lot of tools that you can use out of the box. You can give it the log files and it would just start replaying those logs, ensuring that, because the
Yeah.
toughest part over here is, if two requests came in a microsecond apart, they need to be hit exactly
Hmm.
microseconds apart on your dev setup or on your pre-prod setup, which is
Yeah.
the toughest part. That is where the
Yeah.
tools that you would use needs to be extra sophisticated, because
Yeah.
getting, or like, you can easily bombard 100 requests per second constantly, but you cannot mimic
Hmm.
the exact pattern that you are getting. So that's where the tool needs to be extra sophisticated, that it helps you mimic that
Yeah.
exact same load that you would want to get. Right.
Yeah.
So,
Yeah.
depending on the cloud provider, you have even actually Google, even GCP has a bunch of utilities. AWS has it. JMeter gives you
Hmm.
that. Locust, I've seen in their roadmap, they have something similar. So a lot of tools that you
Hmm.
might already use for load test already has
Yeah.
an ability or a very similar ability to replay your production
Hmm.
traffic over here. Worst case, you can just write a simple Golang script, hardly take some time. You might not be able to do exactly that pattern, but very similar pattern you can very easily mimic. Just iterate through the file line by line and
Absolutely.
start making those requests in concurrent coroutines. So
Yeah.
yeah, that those are the hacks that
Yeah.
you can apply if you don't want to spend time understanding or learning a tool, which in most cases, if you're an early stage startup,
Yeah.
you would not want to do that, but still would want to see how your pre-prod is working. So a simple hack that you can apply.
Makes sense. Makes sense. Yeah. So I think the best is to use, as you said, these sophisticated tools because they give you like a lot of things out of the box. But let's say that you can't use those tools, so you can also go a little manual approach there. So I remember what I did for testing one of our systems was to just go to like a
Hmm.
data warehouse and run some huge query for the last 1 month, get
Hmm.
all the data patterns, like what is the distribution, like what are the top customers and what are the number of requests for these
Hmm.
top customers, and then what is the distribution for the rest of them, and what are the low
Hmm.
volume customers. So based on
Hmm.
that distribution, I wrote a small script, as you said, uh, just created those bunch of data, just randomized data, but following that
Hmm.
distribution pattern, and then use that data to fill in the database, and then figuring out how it goes. And I think matching the production distribution is so critical to reach that, as close as possible to the production environment, because it can go wrong if you are
Hmm.
testing the wrong thing. So how do we ensure that we are testing the right thing?
This happens to everyone, right? This is so basic, but a lot of people make mistake
Yeah.
here. Like you'd have like a lot of people that I've talked to whenever I talk about load testing, or how do you test for basically resilience in the system, they say, yeah, we have tested these
Mm.
API endpoints, but problem lies somewhere else. In most cases, people look in some other direction, but the problem lies somewhere else. So here, that is where having a
Yeah.
small load test locally on your local machine or on a standalone server really helps. Now, how do you know what to test?
Mm.
In most cases, a golden rule that you can follow is start with the database. In most cases, database is always the problem. Check for the database, fire raw SQL queries to see how it is behaving, fire it in the application context, and see if that is going well or not. Database, when you
Yeah.
do when you talk about it, that is easy as in because you have a single component to test. When you put it in the context of your API or your product or your business or your use case, that is where things starts to become a little
Yeah.
complex. Which APIs to test,
Mm.
how you should go about it. Like for example, I've seen people running multi-thread, like they say ki my Python server is not giving me performance, uh, it is not able to handle the load. Now what should I do? Like that's a very generic statement. They were
Mm.
testing for load test on a Python server, but Python
Yeah.
they didn't know as in they did not they it skipped their head that Python is a single threaded language. You cannot
Yeah.
handle large amount of load on a single threaded language. In order for you to do that,
Mm.
you need to run multiprocessors. So that's where servers
Yeah.
like GUnicorn, UWSGI comes into the picture. And the
Yeah.
environment on which they were testing, they were running one worker of GUWSGI or GUnicorn. How are they supposed to get those things? Right. And that was a miss because that was a dev
Yeah.
configuration. So they had a pre-prod configuration or a dev configuration in which the number of workers that were running was just one. And they're saying, Gary, we are not expecting the load.
Mm.
We are not able to handle the load and all. The reason was it is a single threaded. It cannot support the load. You have to run it in multiple processes. Such a
Mm.
trivial thing that people miss. So a thing to very carefully understand whenever you are load testing is understand how your systems behave, understand the core limitation of the
Yeah.
technology stack that you're using. Single threaded language like Python, don't expect concurrency out of it. Have multiprocessing there, right? If you're testing for, if you have, or if you're using a language
Mm.
which is multi-threaded, for example, Golang with Go routines and Java with threads, understand that how, or rather, have you given them enough protection to
Mm.
critical sections in your code? And then you do the load test, because in most cases, what I've seen people doing is they think that, hey, my system is working just fine. It is able to handle large amount of load, but there are data consistency issues, not in the database, but with multi-threaded, they forgot to add synchronized block. They
Yeah.
forgot to add mutexes.
Yeah.
So then kahan se chalega? This is where the problem is. So before directly jumping to the load test, because load test would help you understand the limitation of your API server, limitation of your database, basically limitation of a stateless
Yeah.
component and stateful component. Right? But in order to
Mm.
even reach there, understand the limitation of the technology stack that you have adopted. Understand you are doing those things right. That is where the prerequisite has to be load test on one machine, see if it is working fine. Consistency checks, very important, which is where importance
Mm.
of unit test comes in. That unit test, not just by mimicking or just just basically mocking a few responses, but also a small test on the
Yeah.
concurrency side of things. That are you not losing out on
Mm.
consistency of information? A lot of people miss out on that. And that's where they test something,
Mm.
they're very happy. But then the main problem lies somewhere else, which is
Yeah.
only seen in production, right?
Yeah.
Because they never took that path. And that happens a lot, right? So that is where understanding the path that is taken in production, the path that you are testing
Mm.
are similar. A great way to look at it is uh, what I personally do is for any service that I pick, there are few APIs that needs to always run. They are my critical
Mm.
reads and critical writes that
Yeah.
are load tested every time, every single time. So critical reads and critical writes, as with respect to my application
Yeah.
context or product context, it needs to run. It needs to ensure that it is working fine. Everything else is secondary. Right. So I run those load tests every single time. For example, if I think about any
Mm.
live streaming service, no matter if your entire website is down, every single microservice is down, your live streaming should work just fine. Right. That is a business
Yeah.
critical thing. Every service that you have built there would be one or few endpoints that would be as
Mm.
critical as this. Ensure that those are working fine. Put all of your energy and effort into ensuring your critical reads and critical writes are not failing. For example, streaming of live matches is a critical read. Accepting
Yeah.
payments is a critical write. Everything else is
Absolutely.
secondary. Right. So classifying into right set of tiers and ensuring your tier one always
Mm.
succeeds no matter what, and putting your 80% energy into ensuring your tier one is working fine. Your tier two, tier three doesn't matter to anyone. What matters the most
Absolutely.
is your tier one, your payments and your live streaming. I'm just giving live streaming as an example, but depending on the business, you would have one thing which is extremely critical. So for a product that gives or the product that is used to give or through which people can book movie tickets, booking movie
Mm.
tickets is a critical endpoint that should never fail. For something like basically train ticket booking system, ensure that more than 72 seats are not booked
Yeah.
in a particular bogie. Basic checks. Every single push, every single deployment, ensure that this is
Absolutely.
handled. And it's very context specific, but yeah, approaching from the context view is
Yeah.
very
Yeah. Yeah.
important over there.
Absolutely. So, just to summarize, because that had again so many great points, that I think it boils down to focusing on the basics, knowing your tech stack well, and then knowing your business context well, and then focusing on the top priority, like as you gave examples. So that makes a lot of sense. Now let's move on to different types of testing, right? Or different types of
Hmm,
methods you could apply. So there's one which is load test, but there are other
hmm,
testing strategies, for example injecting chaos in your system, security
hmm,
based testing, and some are related. I think these are all kind of related to load tests, like different flavors of it. uh, for
hmm.
example, there's also something called longevity test, where you just run a load test for a longer duration. So you know some issues that your system might have just because there's a constant load for a longer duration of time. So, what are these general
Hmm.
testing strategies that you have seen organizations implement?
So longevity testing is important. Not always, but you should definitely do it
Yeah,
once a quarter. Longevity test helps you identify memory
absolutely.
leaks in your
Yeah,
program. That is the there are outages that I've seen happening because of machine crashes. That happened because of OOM,
yeah,
basically out of memory. That happened because the code had memory leak. The leak was so small that for a sustained load or for a load for a day or so, you would not
yeah,
be able to identify that. Unless you put it for 2 days, 3 days, then you would see a slight increase in the memory leak. A simple example, very simple example of that is, let's say you put some key in Redis without setting an expiration.
yeah,
Classic
yeah,
example of memory leak, right? And you might say, ki, I have a 32 GB Redis cluster, and you'd not see it fill
yeah.
like that.
Takes time. Yeah,
It would take time because let's say you are adding one key per minute like this without expiration. It would take a very long time for you to
yeah,
see that memory leak. Most people would not even would not even see that
Yeah.
there is a memory leak for that. But eventually it would pile up. Longevity test for identifying memory
Yeah.
leaks is very important. So that is where just few like, and even in that case, you might not even need to, especially if I talk about memory leaks, which is one of the biggest concern, that you might not even need to uh, have a
Mm.
longevity test. Just ensure that you are not setting a key in Redis
Yeah.
without expiration, right? But when it comes to your programming language, let's say you're coding in Java, Java memory leak
Yeah.
problem is so real. And with memory leaks, how would you know about it? And with Java, if you are leaking memory due to any reason, it would take a very long
Yeah.
time for it to pile up. You would
Yeah.
not see a clear pattern. So that is where you may not want to run a
Mm.
sustained load test, but at least a longer duration continuous load on
Yeah.
a parallel setup. Again, luxury for a company who has a lot of money. A startup might want to say, "Ki, I'll
Yeah.
just do a reboot of my
That
machine,"
works.
right? So, a different companies, different strategies. Ideal world, you might want to have that longevity test to identify memory leaks, which your engineers are not able to
Yeah.
identify. Maybe application code is not with you. Maybe you're using Elasticsearch and Elasticsearch has a memory leak. Maybe you're using a library and that library is
Absolutely.
causing a memory leak.
Yeah.
It's not under your control. You have checked your code. Right. So relying on some third-party vendors or libraries might
Yeah.
induce those things. Those are important because for you
Yeah.
that's a black box. And if that takes your system down, then your users, you can't say, yeah, it was that package that took us down, not our fault. Your users would say, I
Yeah.
gave my money to you, you give me the service. I don't know
Yeah.
what you're
Yeah.
doing behind the scenes. Right. So that's a longevity test is very important. But again, a luxury for most organizations. But it
Absolutely.
do that. And you talked about security. That's a great point. Security testing is very important. Data leaking due to any reason, you should not be leaking data of your customer, especially PII, like
Yeah.
your social security number, Aadhaar number, PAN card, birth date, email ID, like birth date. Most people don't know birth date is a PII information. They don't know. They hand out their birth dates
Yeah.
like that. You should not be doing that. Someone having a birth date can deduce so much
Yeah.
of
Maybe
information about you.
passwords.
So yeah, passwords, right? So there are so many things that people hand out. So that's where security testing is very important because no matter what happens, facing a data breach or
Mm.
having a data breach could last or could basically take down your brand
Yeah.
in a day. You not
Yeah.
even know about it. What struck you, and that information, that loss of trust, that's gone. It takes
Yeah.
years to build it again. And it's not that, hey, most country or most people might say, hey, it's okay, a lot of information is
Mm.
anyway out. For a company, it is catastrophic because the hacker who has done it
Yeah.
asks money. You pay at least $1 million. I've seen deals signing up for $1 million, couple of $1 million
Yeah.
for ransom. You know, hey, I'll delete the data only if you pay me
Absolutely.
$1 million. That is like people ask to, it's monetary loss, it's status loss, it's effort of our engineers going into
Yeah.
making that secure. But you just do
Yeah.
it beforehand only. Like basic checks, like genuinely Pareto principle is the best
Yeah.
principle out there.
Yeah.
80-20 rule. With just 20% of effort, you can make 80% of your infrastructure secure. Most of the
Mm.
attacks are broken. You they cannot
Yeah.
infiltrate your system. It's very difficult to go beyond that. Most people don't just miss those basic things. Don't do that. Ensure that your security
Yeah.
is tightened. Now, how do you test it? There are tools. A lot of things. There are tools that you can directly use. For
Mm.
example, Prowler is a great tool. Cloud Custodian, both open source. You don't need to even pay a
Yeah.
single penny to do that. Prowler, Cloud Custodian, great tools. There is something called as Engine. I forgot the name. That is also a great tool that gives you through it tries to reduce so much of information. I was shell shocked with what are it's trying to reduce, but it gives you leaked subdomains that points to a
Mm.
dangling IP, all of that. Have those checks running in your
Yeah.
infrastructure
Yeah.
every now and then. Keep an eye on the critical vulnerabilities, package upgrades, all of that. Like you don't need a sophisticated
Yeah.
testing setup. It's all about discovering them using already existing tools. You don't
Yeah.
need to pay money. But if you are rich enough or a company is rich enough, go for a Prisma subscription. Prisma does a
Yeah.
fab job in Prisma is a product from the
Hmm.
Palo Alto networks that does this entire security audit of your system. You just have to do click, click, click. It installs in your infra and
Yeah,
it scans it. It shows you a lot of stuff and which you can just go and fix and done. Right. So that's how important. It's very important to do security testing. Not in the flavor of load testing, but again a supercritical component, especially senior engineers like basically tech lead and above, they have to be very thoughtful of this. Key security is not broken, data
yeah,
breach doesn't happen, no matter what. Right set of encryption, encryption at rest, encryption in transit, multi-level encryption,
yeah,
whatnot, and all of that comes in handy. So yeah, but again, in a gist, use a lot of tools. GitHub has a lot of great tools. Prowler is superb. Cloud
yeah,
Custodian is superb. Use that. Use that to have regular scans of your infrastructure so that you are
absolutely.
secure.
So, I think, yeah, so security, like data leaks and all, it just destroys a company because customer trust is completely lost. And doing all these testing beforehand pays really well because uh, when things go wrong, you don't have time to react, and you don't have energy to do that because there are so many things going wrong at once, because mostly there are like cascading failures, so one thing fails and then the other fails. But there is like other aspect of like securing your system, which is from attacks. So these are attacks where they want to consume resources of your services, right? And like a DDoS
Hmm.
attack where they just try to do something, some operation at a very high scale, and then they consume your resources,
Hmm.
and those resources are no more available for the regular production traffic. So how do we
Hmm.
deal with that? What are the strategies to that?
Uh, Not like the way I have typically approached this, again,
Yeah.
very baby steps, because it's very, that's how I would also want to go about it, because damaging information, damaging of image, brand, and whatnot, it's
Yeah.
very catastrophic. It's always that basic prevention is
Yeah.
better than cure. Just put in effort. Most companies
Yeah.
are reactive. Most companies are reactive, especially when you talk
Mm.
about security, right? Instead of being reactive, be
Yeah.
proactive. Be proactive in identifying. It just takes couple of minutes to run a scan. AWS does it for you
Yeah.
for free. Run that, fix that, done. Right? Instead of spending money into building a massive team and doing that, a normal engineer with 2 or 3 engineers, 1 week task, they could make your infrastructure secure. Like I rotated infrastructure in 6 days, entire infrastructure to make
Yeah.
it secure. It doesn't take a
Yeah.
long time, right? It just requires you to have that patience and that sustenance. Ki, I want to do this for 6 days straight, but unless not wait for a data breach to happen and then you do it. Do
Yeah.
it before
Yeah.
instead of.
Makes sense. Great. So I think we talked about like different types of testing as well, except the
Hmm.
chaos part of it, where we
Yes.
inject some known failures and see how our
Yeah.
system behaves. So I've seen some libraries being used just to inject like network latency, or disk
Hmm.
going full, or some packet loss, or maybe like complete
Hmm.
availability zone, or data center going down, and all those things. I think
Hmm.
they help us
Hmm.
identify all those issues beforehand, and looking at even
Hmm.
small things. So we might have, so if there is a network failure or network latency shooting up, we
Hmm.
have
Hmm.
timeouts, and then we retry. So we need to also make sure that retrying is happening and it's not impacting some other
Hmm.
things, like we are retrying in a way so that it is exponential back off with a little bit of jitter, and it's not impacting the service which is already facing some issues. So what are some
Hmm.
things that are identified by doing all this testing, and how frequently should it be done?
Chaos testing is great. I love the concept. Almost pioneered by
Yeah.
Netflix with their tool called
Yeah.
Chaos Monkey. Brilliant way. But if you think about it, chaos testing is something that, like most days, today, most companies that spun up, they are all
Mm.
cloud native. They take cloud services
Yeah.
for granted. They think that cloud service would never go down. That's why you see when S3 has an outage, the entire internet is gone, right? Because people take
Yeah.
it for granted. But When you think about it, companies like Netflix, they cannot afford, and they cannot say ki, Arey, AWS is down because of
Yeah.
which we are down. Because if Netflix is down, their stock price falls
Yeah.
immediately. People lose trust. Right. So that is where, especially for a company who would not want to tie themselves or their existence with the existence of the or with the uptime of the cloud provider, they have to think about chaos testing a
Mm.
lot. That even if my cloud provider goes down, I should not be able to, or I should not
Yeah.
face an issue. That's where what typically what Chaos Monkey does, randomly deletes a
Mm.
load balancer, randomly deletes a server, and see how we
Yeah.
perform it. So for stateless components, it's very easy, right? Where you might have a server, a bunch of servers behind a load balancer. Even if one of the server goes down, you are not
Yeah.
impacted at all. The request would stop going to that server. Only the request that that server was currently handling
Yeah.
gets affected, right? But when that happens, have you handled your database consistency well or not? That is what becomes interesting. So Chaos Monkey, most people, so why I'm talking about this, Chaos Monkey, most people think is about detaching yourself from cloud. That is
Mm.
partially true. Not completely true, but partially true. That's why most companies do not adopt chaos testing because they think, when would a cloud provider go down?
Yeah.
And if that goes on, anyway, 30% of internet is down. But basically, why should I care? But they miss out on the fact that Chaos Monkey, it would not just terminate your AWS resources or your
Mm.
cloud resources. It would give you that
Yeah.
glimpse that is your data even remaining, or does your data remain to be consistent even if
Yeah.
there is an outage, or even if your cloud is down, or even if your let's say you you basically preemptively shut down your API servers, you remove your auto
Yeah.
scaling group, or as you talk about it, that you delete your entire
Mm.
availability zone. So do you have a fallback
Yeah.
for that? You might not need that degree
Yeah.
of testing, but at least basic stuff is something that you have to, again, Pareto principle, apply those things to 20% of your basic things. That would keep you
Mm.
handy, or that would keep you up for 80% of your time. That basic consistency issue, most companies struggle with that. I've seen people running scripts in production data in order to fix a consistency issue. Why? Why are you not using transactions? And they say we don't know about it. Why did you not know about it? Chaos testing, it's not just to think about, like a great example that you gave is, what if your disk
Yeah.
is full? Most companies don't even handle that. They think, "Eh, this would never
Yeah.
get full." And then one fine day it happens that on your Jenkins server, your disk is full. Now suddenly no one's able to
Yeah.
deploy things. Right? Having that ability to, or having that privilege to see how your system would react and be prepared for it is extremely
Yeah.
critical. And again, chaos testing, most people think it's privilege. What my perception or what my views for that is, use basic features of chaos testing to check for data
Yeah.
consistency, because most companies don't have this basic things done right. Once that is done, go to the next level and then think about injecting failures. For example, network getting
Yeah.
throttled. Such a simple case, that network getting throttled, how would you respond? Because that would very surely tell you synchronous dependency all around the system. One network throttles,
Yeah.
cascading failure. This would happen in production. It would take you hours to do that because a lot of services along the path
Yeah.
is down. So then it would help you uncover unnecessary synchronous dependency in your
Mm.
infrastructure. Why are you not solving it? Try to make things as asynchronous as possible. Why are you not doing it? Chaos testing helps you
Yeah.
uncover that. So you don't need advanced features what
Yeah.
Netflix does. At least use the tool and do the basic
Absolutely.
things. If basic things are done, you're already covering 80% of your use cases with just 20%
Yeah.
of your efforts.
Again, yeah. As you said, Pareto principle is such a relevant principle that we need every day. So 80% of the things when are covered. So a lot of things you don't need to worry about. And I think
Yeah.
the idea of like chaos testing is to not or try not to leave any surprises and test as much as possible, but go very basic and then reach the next level. And don't try to say, okay, I don't have like enough infrastructure to install chaos monkey and do the Netflix type of testing. You don't need to, because you're not
You
Netflix,
don't
right?
need to.
You can just do some basic testing, inject some basic faults and test data consistency, your configuration on retries, timeouts, and some other things, and that should be good enough. So with this surprise, like since we were talking about AZ going down, so I think AWS had some issues, and
Hmm.
we were dependent on PagerDuty, I think, and
Hmm.
so AWS going down, we also impacted, but PagerDuty was also impacted, and then we did not get any pages. So that was a like funny thing. So we did not know that there is something wrong unless like we fall back to some other alerting mechanism, and we got to know. But
I'll give a good example on that. So we have two alerting
mm,
mechanisms. We use PagerDuty to get ourselves notified when something's down. Uh, but for in order to see what's up and what's
mm,
down, we have our internal monitoring system. But on top of that, we use an
yeah,
external service to monitor it from an external internet's
mm,
point of view. So that even if PagerDuty is down or our monitoring system is down or internet is cut off, something happens, we still have an external view to at least get ourselves
yeah,
notified. And that doesn't work on
yeah.
PagerDuty. That is different. So that even if a fragment is down, we are not aware, at least we get paged to know if something's down.
Absolutely. Yeah, that makes a lot of sense.
Having a fallback even for a fallback.
Yeah, fallback for fallbacks. That always works. Um, Great. So I think we have covered a lot of things here in terms of testing and how we can focus on basics and then move forward incrementally.
Hmm.
What are the key metrics that we should monitor while we are doing all this? So, because there are so many different kinds of component, there is cache, there is
Hmm.
database, there is API servers, there is stateful streaming processes, there can be load balancers and whatnot. So these different
Hmm.
systems have some things
Hmm.
in common to monitor, but also have different things to monitor. For example, if we start with database, what are the key metrics that we should monitor?
For database, the key things that everyone monitors is CPU, memory. Eh, Very few people keep an eye on the disk. There are no, I've seen databases with no alerts on
Yeah,
disk usage or disk consumption. I mean, disk, disk should be measured. You need to know how your disk is getting
yeah,
filled, right? And most people, with respect to database, CPU, memory, disk is there. Apart from that, how much is the cache hit ratio? Even on the database, there are
yeah,
caches. You need to know what is the cache hit ratio of your database. How is your query execution plan? Slow queries monitoring, right? You need to know which queries are
yeah,
frequent, which queries are frequently slow, which queries are infrequently slow, and which queries are very frequent, not slow, but they are thrown at you at a very
yeah,
large number. So monitoring those details is very
yeah,
important because it gives you that
yeah,
idea, it gives you that
yeah,
sense around, because again, you think I might be reiterating that same thing again, Pareto principle, that going by improving on your slow queries that you have, tackling 10% or solving 20% of your slow queries would give you 80% of your performance gain.
absolutely.
Like I've done that, I've seen that, like just measuring slow queries that you have in your systems. Frequent slow queries are the best place, low hanging fruits to crack, and you would suddenly see a dip in the response time, and everyone in the company would be like, oh, what an amazing engineer you are. All you did is just remove that extra gen that that query was
Yeah,
making, and which you did not want. Or like you had no need of making that join. Some developer wrote that, you just removed it, but everyone's
yeah,
praising you. Low hanging fruit. Again, you don't need to know very in depth on how MySQL or Postgres
yeah,
works. You can still do your job very well. So having monitoring on slow queries, frequent queries, frequently slow queries, infrequently slow queries, very
yeah,
important. Apart from that, cache hit ratio, you need to monitor disk utilization, IO, a number of IO operations that
yeah,
happens, disk consumption that happens, all of that very important for a database site.
absolutely. Yeah. Uh, so I think you shared this like Pareto principle that one slow query might be impacting a lot of other things. So this happened to me as well. So there was just one slow query. It was part of like a long running job which would run every let's say periodically every hour or something. And when it
Hmm,
runs, it it takes away a lot of resources because it was such a
hmm,
huge query. And then it
hmm,
also had like some other impacts on some other queries which were not that huge. So that one query was creating so many alerts for us that we had to look at it, like why it is happening periodically, and we were not aware because it was a legacy system. There was some job running, and then
Mm.
we tried to optimize it and got rid of, let's say, 80% of our alerts. So that is really critical. So I think cache hit ratio and the query plan cache, and these things are really critical for database. What are the key metrics for, let's say, an API server?
API server, I'd break it into
Hmm.
two. When you say API server, I'd also want to include asynchronous workers as well.
Okay.
So when I talk about API servers, a very interesting dilemma happens. Again, you would monitor CPU and memory. That's the chalo, let's do
Basic.
that. But you should also monitor the
Hmm.
network. Why? Because I was working on a project that you'd see, array, CPU is just 2% utilized, memory is just 5% utilized. The entire thing was network heavy.
Yeah.
Entire thing was network heavy. We said, hey, chalo, scale it down. Because 2% and 5%, I can easily scale it down by 50% and would work just
Yeah.
fine. The machine was scaled up to have a better network card
Hmm.
because it was very network heavy
Yeah.
system. Because it was very network heavy system, taking that stupid decision of scaling it down on CPU and memory was a bad decision.
Yeah.
So that is where how good your network is doing. How many, so key metrics, bytes out and bytes in. Keep an eye on
Yeah.
that. If your system is network heavy, then see if you have provisioned it well or
Hmm.
not. So CPU, metric, network, disk, four very basic things that you would want to monitor. For API servers, you need to know how many requests per second it
Yeah.
handles. You can get it through target group on AWS. You can use Prometheus to monitor it. Nginx logs, you can stream so many ways to measure it, but that should not be a blind spot.
Yeah.
Never have the number of requests coming to your API server be a blind spot for you
Yeah.
because that is a way for you to understand the limit of your API server.
Absolutely.
That at what time it starts to throttle. That would give you an idea for your load test how much one instance can
Yeah.
handle. Numbers are right there. Most people cannot just connect the
Hmm.
dots. Right? Understand how many requests are going to an API server without it throttling. Okay, coming to throttling. How would you know that something is throttling? These would be not out of the box metrics. This would be your within application
Hmm.
metrics. Right? So something that is you got a request and then you are throttling. So when you get a request and then you are throttling, only your application knows that you are
Yeah.
throttled. So export those metrics. Export those metrics on how many times did you have to
Yeah.
throttle. If you don't know how many times you had to throttle and at what time did you have to throttle and what was the root cause for it, how will you optimize it?
Definitely.
Because ideally, throttling should be zero unless that is the plan,
Yeah.
right? For example, if you're having a tiered plan for your customers
Hmm.
like bronze, silver, and gold, you might want to throttle
Yeah.
them, right? And that's perfectly
Yeah.
fine. But if that is not intentional, you need to know why are you throttling.
Exactly.
And if you don't have throttling, first implement throttling. Like every system should have throttling.
Absolutely.
Coming to that,
Absolutely.
right? So for API servers specifically, you should know these basic metrics. Coming to the part around asynchronous workers, see how many messages are unread,
Hmm.
or how many messages are in flight, or how many messages are there in your message
Hmm.
broker. One metric that most people avoid, I don't know why, because the time that your message spends in the queue is the wait time, that unnecessary time which you could have used to immediately process the
Yeah.
request. So if that is part of your SLA, that for example, if you're doing asynchronous count plus plus on the likes on a blog,
Hmm.
let's say you'd want to have an SLA of 5 seconds. So within 5 seconds, a person hitting the like button on Instagram, the count should be getting plus plus in your database. How would you measure that? Unless you know what to
Yeah.
measure, or unless you're measuring, you would not
Yeah.
know that how much time it is taking for you to update it. Because if you're breaching the SLA, you would increase the number of servers. Measure the number of messages in your queue and see if how long would it take for you to process those many messages and consume them. On your asynchronous workers, again, disk utilization. So there might be some processes which are disk heavy. Or one more great example on that. A service which is doing, let's say, encryption decryption. You cannot judge an encryption decryption service on memory.
Yeah.
That is CPU heavy process. Right? Understand the workload.
Yeah.
Like if you're doing video processing is an asynchronous job. You not do synchronously. If you're measuring your video processing job's output on the memory consumption of it or network consumption of it,
Hmm.
that's stupid. That is a CPU intensive job.
Yeah.
So it requires large core. Now, if you do video processing on Python, That is the worst thing that you can do. You should do it on C++.
Yeah.
Use a Python binding, or in Python use a C binding, but it should be at the end a core C++ process. So you need to know how much time is it taking for you to do that. So no, leave no stones unturned, measure everything and anything. Some things come out of the box, something you have to explicitly measure and send.
Yeah.
So you can use Prometheus to export all the metrics and capture it and then analyze it. But analytics super important for you to take an informed decision and good architectural design.
Absolutely. So many great points there again. Just to add one example from my experience here, where you said like measuring anything which might be critical is so important because first of all you need to know what kind of job it is it IO intensive, CPU intensive, memory intensive, and then monitor those things and optimize on that later. So we were running like a Kafka streams application which uses which had state. We're also storing state, and it uses rocks db uh,
Hmm.
for storing the state, and which needs ssds to perform well because it is optimized for
Hmm.
ssds. And we did not know, we were like, I was a application developer, right? I was running my business logic and I did not know what to monitor. I was just monitoring my throughput, and that's good enough. But then suddenly we like had so much scale, so many events, and we faced that, oh, something is wrong, my throughput is really slow. And then we reached out to Kafka people because they were the experts, and they said that, you know what, getting the data from the state store is extremely slow because you have not
Hmm.
provisioned the right machines for running these Kafka applications, because it needs
Hmm.
ssds. You're not using ssds. So being curious like what can go wrong and monitoring the right thing is extremely important. And it comes with experience. When things go wrong, you will start, oh, this is also something to monitor, let's do that. So but yeah, I think you covered very nicely what are the like key metrics that everyone should think about when they are running these application into production. And it boils down to, understanding the bottlenecks, and then using that data, whatever you're measuring, to load test and chaos test and do all those kind of testing. So great. I think I enjoyed a lot, kind of discussing all these, real testing strategies and ensuring scalability and fault tolerance. And I think, just to summarize, if we had to summarize whatever we discussed so far, I think the most important point was to start very basic, because we talked about it so many times and in different context. So I think it's very important for us to start
Yeah.
basic, uh, and then incrementally progress, make progress, and grow at a next level. Don't think at the next level before and do nothing at all. So instead of that, start basic, know your tech stack very well, as you covered so many points on
Yeah.
choosing the right tech stack, why is it important, and what are the use cases. It's so important. And then the third one was to be prepared, not leave any surprises. And I think with that, um, uh, it's it becomes clear, like scalability and fault tolerance, these are like seemingly so fancy concepts that you need some high architecture decisions to make. But at the end, I think it boils down to the basics and the way we do engineering. So if you have to summarize our session, did I miss anything? Or
No, no, no. Very like very, very basically very beautifully put. Just 3 points. Start small. Most people make mistakes
yeah.
in the early stage. Like they just directly think, hey, I need the best thing out there. You don't. Start small. See if you even need that.
Yeah.
If you need it, because then grow your engineering maturity would grow over time. You're If you're early, you cannot just expect, yeah, I'll do chaos testing on day zero. Hey, is your product even surviving 1 month? No, right? Don't do that. Don't do that.
Yeah.
See, take baby steps, and which is where, you know, more than saying yes to everything, it's very important to say no.
Mm.
Don't do it, right? And that's where authoritative leaders come in.
Yeah.
Like leaders, more importantly, leaders always, like, you think the leaders need to say yes a lot? No, they have to say no a lot.
Mm.
No, I'm not doing this. I'm not doing this. We should not do this. So most of the decisions that leaders challenge
Yeah.
is this: don't do this. Wait, you don't need to over optimize. For example, data migration, we do a lot of data migration. Best procedure from day zero. Don't do this. Start small. Do a full table copy.
Yeah.
That works. And
Absolutely.
yeah,
Absolutely.
that's the job.
Great.
But very, very well summarized on that.
Cool. Thanks. So, I again thank you for coming onto the podcast and sharing all those valuable insights from your experience. For the audience, I think you will get a lot of valuable insights from this episode. Please subscribe to the channel, and if you want to, learn from Arpit, go to his channel, Asli Engineering. It's available on YouTube. He's also sharing a lot of newsletters, and also check out his system design course. And I hope you really enjoy this episode. So thanks a
Yeah.
lot. Thanks, Arpit, for joining.
Yeah, thanks a ton, Cavalier, for hosting it. You were fab. बहुत मजा आया. Loved it.
Thank you.